So I'm just going to go through a couple of things before we start the presentations. I just wanted to cover the support channels at ilifu. So the primary point of contact for support related issues is the email address support@ilifu.ac.za. Behind this email is our ticketing system, where our support staff will receive your emails and will be able to assist you with any issues. Our user documentation is at docs.ilifu.ac.za. So I'll just quickly give a demo of our documentation. So here's the site. It's broken down into a getting started section, which is basically a step-by-step guide on how to use ilifu services. And then there are more advanced topics or documentation in the technical documentation section. These often expand on topics covered in the Getting Started guide and also have domain-specific information for astronomy, bioinformatics, and services like data transfer. We also have an ilifu status page at status.ilifu.ac.za. So you can come here to view the status of the system. So it's always good if you are experiencing an issue to come and check this page first to see if there's something reported. Otherwise, if not, please do contact us via the support channel. But here you can see a general support status, and then the different sections or services of the cluster are listed as part of the page, and any incidents will be reported on this page. And then finally, in terms of our training videos, as I mentioned, we do record these and put the presentations up on our website. So this is at the ilifu.ac.za website. And so the example of the previous training sessions are available here. So under accessing the facilities training, and these are from March this year. The slides as well as the videos are available. And previous year's training is also available. Obviously, the more up-to-date training videos are recommended because when we release new features, we would include them in the later training videos. So in terms of the topics we're covering today, the majority of the topics today are kind of expansions on what we copied in the introduction session. So Robin will be taking us through software environments, touching on Python virtual environments and R containers in RStudio. Then Hope will take us through advanced SLURM usage and interactive sessions in SLURM, as well as touching on the best practices, which is always good to cover. And then Jordan will take us through the data transfer services that we have on offer at ilifu.
Right, so in the basic training, I spoke a bit about the various software environments we use. Today, I'm going to be going a bit more in depth here, and I'll be speaking mainly about Python virtual environments and some use cases, and also how you can use R and RStudio. I don't think we're going to have time to get into Singularity containers, but I have included some links and some slides, which you can have a look at if you'd like, and also feel free to contact me if you're more interested in container related stuff. Okay, so a virtual environment is an isolated Python environment where a project's dependencies are installed in a different directory from those that are installed in the system's default Python path, as well as other virtual environments. So there are a few virtual environment packages. We've got virtualenv installed directly on the cluster, so you can use that anywhere without any modules loaded. We like to encourage you to use virtual environments instead of using this command pip install -- user here, where you can install a particular package for your account. This has caused some conflicts in the past, and it can get messy. So yeah, preferable if you use a virtual environment. And finally, you can choose which Python you want in a virtual environment, and the packages you'll be able to install within it are limited by that Python OS. So it's important that you understand which versions of libraries you need and which version of Python is going to accommodate those. So here we've got some basic virtualenv commands. Help will give you more information on the virtualenv package itself. And then you can also create an environment using the virtualenv command, and then the path to the environment is just where you want it to live. And then the Python flag will let you choose which version of Python you want to use. And the system site packages flag tells the environment basically that the packages installed on your computer, so outside of the virtual environment, will also be added to the environment. So here's an example of creating a virtual environment, which I'm going to continue to use throughout the slides. So virtualenv, the tilde / denotes that I want to create this in my home directory, and the .jupenv is the name of the virtual environment. Then I use source jupenv, and then inside the virtual environment that's been created, we use the bin activate script to activate the virtual environment. And then the third line that you see here with the .jupenv in brackets is what you'll see when the environment is active. So the .jupenv in the brackets shows that you're inside your created virtual environment, and then you can use which Python to check the version of Python that you're using. And then finally, you can install whatever Python packages you want. So here's an example. I'm installing scikit-learn. And then finally, you can use the activate to get out of your Python virtual environment. So an interesting use case for creating a virtual environment is to use it as a Jupyter kernel. So once your virtual environment is active, you need to install the IPython kernel software and this is also where you'll give it a name. And then you can set your virtualenv as a kernel by using this example. So we are, once the environment is activated, we pip install Jupyter, and that's going to install all the packages that the Jupyter environment needs for you to run code in the notebook format. And then we'll do the IPython install and name the kernel. And then this last line here, install kernel spec, that's telling us where the kernel has been installed. So creates the kernel.json file at that location. And that'll be, you can see it's got my username there. So that'll be particular to your account on the cluster. And then if I fire up a session on Jupyter Hub, you'll see that the custom kernel that I created is available to use, which is pretty cool. Okay, so now moving on to using R and RStudio. I'll go through an example of launching RStudio using cluster resources, and I'll also demo this at the end because there are a couple of sort of tricky caveats here. So when logged into SLURM, you can allocate some resources using the srun command, which I've got here at the top. And then we need to add an R module that has RStudio with it. So that's the second line here. And then running the RStudio command will return quite a bit of information here. But the important part is the SSH command that I've got highlighted here. So what you'll need to do is then copy this SSH command and run it from your local machine. And then that's going to let you run RStudio in your computer's web browser, but using cluster resources. So localhost here just means your computer. And this is what it'll look like. You'll navigate to localhost 8081. That's just the port that the web service runs on. And you'll be able to use RStudio. So yeah, as I said, I don't think time's going to allow us to go through Singularity, but I do encourage you to go and have a look at this link. It's just the Singularity documentation. So yeah, it's really great documentation. There's a lot of useful stuff here. Everything you'll need to build basic containers. I'm just going to skip through these. Cool. So now I'm going to just demo the RStudio stuff, and then I will quickly summarize and then hand back to Hope. Okay, cool. So I hope everyone can see my massive terminal that I've got here. So as I said, we're going to need to run this srun command to allocate some resources. So don't worry too much about these flags. These are just basically the size of the job that I want to allocate. So let's run that. Hopefully this doesn't take too long. Cool. Cool. So now you can see I'm on compute 004. So I'm actually on one of the worker nodes. And if I want to use R, I need to find an R module. So I can type in module avail. And this should show me available modules, I hope, in reasonable time. Cool. Okay. Right, so I'm looking for an R module. So, and I also need an R module that has RStudio installed. So I'm just going to grab this one and add it. Cool. So now if I go module avail again, you should see an L next to the module that you've loaded. So that shows you that this is the module that you're currently using. And then if I simply type RStudio, so again, there's quite a lot of output here, but I'm just concerned with this SSH command. So I'm just going to copy that. Cool, thanks. Cool, so I'm just going to paste that command. So now you can see I'm on this compute node, but this is from my local machine. So now I just need to stop share again and go to my web browser, which is where cool. So can everyone see the RStudio login?
Yeah, you can probably zoom in, Robin, if you want.
Right, yeah,
but,
sorry.
Yeah, that looks great.
So, sorry, I'm just trying to get the, so when you do this, I forgot to mention that when I run these SSH commands, SSH is going to give me a password. So this is going to be different each time you run this command. I'm just going to copy that. And your username will be your account, your ilifu account username. So that's Rob H for me. And if I paste that, I should be able to sign into RStudio. Cool, and there we have it. So you can see I've got all my my working directory files from the cluster available to me. Yeah, I don't really use RStudio, but here it is. So in summary, when it comes to the various software environments we've got, there are obviously certain use cases for each one, and we encourage you to explore the different environments so you can figure out what's best for your needs. So virtual environments are great for like rapid development and prototyping, and they can also be used by a group if they're created in a shared directory. Modules are useful for when you may need a version of software that isn't containerized. Some modules are also used to execute containers more conveniently. So for the astronomers, the Casa module, for example, which can be used to run particular packages from the Casa 6 container. And then finally, containers themselves are best for reproducibility and sharing, and are the best way to run a heavy application on the cluster through SLURM. Yeah, thanks for listening. I'm going to hand over to Hope now.
Good morning, everyone. So yeah, thanks, Owen, for that. So I'll be going through the advanced SLURM usage. The last time I was doing the basic usage, and then after that, I'll show an interactive session demo of. Last time I showed the S-batch demo, but today I'll show interactive session. So I will start by reiterating the use cases I mentioned in the basic training session. So where we have our login node, the Jupyter dev node, and then the main partition and the high mem and GPU. So as I've mentioned before, for the login node, it's basically where you do your basic admin stuff, running bash commands and SLURM commands. And then within your Jupyter node, it can be thought as a development space where you're testing software, plotting results, or anything that's not taking too long to run. And then you have your main partition, commonly where most of the computational heavy processing happens, where you have heavy jobs, and then you have the high mem. The high mem, I didn't go too deep into it in the last training session, but today I'll just get into it. So for the different use cases that we have, these are the computing services that we offer. We have the main partition, the high mem partition, GPU, the GPU V100, that sounds fast, and the development partition. So the second row is the number of nodes present within each partition. And then the third row shows the specifications per node in each partition. So this so far is an efficient platform that caters for different users that are using our system, and for any other new users that will be coming onto our system. So this caters for different science scenarios that any user wants to explore or run for whatever work they're doing. So basically, happy customers, happy science, and we all get the state-of-the-art results, and then we improve machines to keep crunching away. So basically, this is the platform that we offer and how everything is interconnected. And then, so now getting into the advanced usage of SLURM, here I start with the two commands, sinfo and saccount manager. I will say that just as a rule of thumb, you want to check out these commands just before running or submitting a particular job. So basically, sinfo gives you information of the resources that are available on the cluster. And then saccount manager tells you about the accounting groups that you are part of, either many or one. This one is useful in the sense that you may be part of multiple groups on the cluster. And when you want to run anything, you want to make sure that you do that under the correct accounting group. Then the following shows, so the following here, srun, syntax for xrun, shows the allocation of the resources and setting the accounting group. So this is using srun, which is an interactive session of SLURM, rather than submitting an S job, which I will show later within the demo. So moving forward, then now, once you have your job running or your job completed after knowing which resources to use, what accounting group you are, you can inspect SLURM and get information about your jobs. The two useful commands to note here is scontrol and saccount. So basically, scontrol gives you information about the job that's currently running, and saccount allows you to inspect your completed jobs. So you can make comparisons between the resources you allocated for the job and how much of those resources were used by the job, so that you also can learn next time if you want to allocate the same resources that you can use them efficiently. A very useful case for saccount is basically pulling up all your jobs that were completed or not, even if they failed, between two specific dates of interest. So here I used this to pull up the jobs that I ran between the 1st of September and the 14th. So to pull up everything within that time that I ran. Then furthermore, other useful information is knowing when your job is starting, completed, failed, or went over the expected time that you gave it, without having to sit there and keep watching the queue and waiting for the job. So yeah, I show this now with an example of using the interactive session, but this can also be specified when submitting an S-Batch job to SLURM, or when you're going on a holiday. So you are able to set the mail user and the mail type to get when your job starts, when your job ends, when your job fails, when your job goes above the time that you allocated it. You can also exclude problematic compute nodes. That's if you know, or we know that there's some nodes within the cluster that are problematic. So you can, when you do the SRun, because it gives you randomly gives you a compute node within the partition that you selected, or that's default. So you can exclude some of the compute nodes that you might know that they are problematic. So now we get to the part where we're running an interactive session. Basically, an interactive session allows you to connect to a computing node and work on that node directly. So this may be for quick development, and if you don't want to wait in the queue. So to start off this, you need to use when SSHing to the cluster, you need to use the Y parameter. I'll show why that's needed in a few. This allows X11 forwarding. I'll explain that as I do the demo as well and show it. So once we've logged into the cluster, then we can either use S-Interactive or SRun. So basically S-Interactive is just a wrapper around the SRun. So once you have that, you can start processing manually. So this allows you to run your jobs and see them run in real time. And then, so when running an interactive session, basically try to specify a lower wall time and allocating less memory to increase the chances of the job being launched immediately, because you don't want to be running something that's very long and watching it run for that long. You might close the terminal by mistake, all the job there would be lost. So this is just for doing quick development work or wanting to run something on the fly without having to wait on the queue or anything like that. So to just explain every step here, I use SRun. So I use SRun to start the batch session for 10 seconds, where I allocate 1 gig of memory to the certain compute node that's going to be allocated to me. Then in that compute node, I start a singularity container and then run Python 3 for my job script. So basically you could either run this in two ways, either step by step on the command line, and also just one command in the command line without having to do the step by step. And then after that, you of course need to do manual processing after that. So now I'll just go into the demo and then just show everything that I've spoke about up until this far. So as I mentioned, logging into the system, you need to specify the Y parameter. So that allows us to, if you're gonna be running some software that has a GUI interface, then we can use that graphical user interface. So logging in, and then just navigate to my yeah, so as I mentioned before, just before running anything, you want to check what resources there are in the cluster. So basically using sinfo to check what partitions are available, the CPUs, and if anything is available as well. So here you see the partition, the availability of them, the CPUs for each partition, the number of nodes, the memory allocated for each partition, and the state in which that partition is in. And then also another useful command is basically using SQ. So SQ just shows you everything that's in the queue, but generally you don't want to see everything that's in the queue, but rather what you have in the queue. So far I don't have anything in the queue. And then for the checking, so just using the S account. So the S account basically pulls up every job that I ran between the 1st of September and up until the 14th. So these are all the jobs that I ran, either completed, canceled, or failed. And then, so let's start the interactive session. So that's using SLURM. You can either use as interactive or SLURM. So we have chosen to use SLURM. So now, yeah, we've been allocated resources and we are on compute node 065, 064. And then, so what I mentioned earlier with the Y parameter having an interface, having software that could use, that has a GUI, and then you want to use that. Yeah, I'll just show an example of so that popped up somewhere. I'll show what the pop-up was. So this is what popped up. So we have a software called XMessage that basically has a graphical user interface, and this is the graphical user interface. So that Y parameter allows us to be able to use the graphical user interface. So I'm just getting back. So now I can get back to basically starting our interactive session. So here, basically, I start up a Singularity shell, and within that Singularity shell, I start up the Python container. Then within that Python container, I start up Python and then basically run my job script. So here, the job script that I'm running is basically a game called tic-tac-toe. And then I just play around with the computer. So I'm player X and then the computer is player 0. So that's 1. Oh, it's actually the first time I'm winning this game with against the computer. So yeah, this is basically allowing me, the interactive session allows me to interact with whatever code that I have or whatever job that I'll be running with, instead of submitting an S batch to SLURM. But usually it's best to submit an S batch, because with this, if I close my terminal by mistake, I might lose all the job that I was running. Or you don't want to be just running on a compute node without basically the login node maybe might be rebooted or started, and then you might lose all the job that you were running on the interactive session. So yes, that's the end of the demo. And then just getting back to so moving on, here I talk about array jobs. So the idea here is that if you have a single job that you want to run many different instances of. For example, if you are simulating particles in a cube and you want to run the same simulation multiple times, but with different input parameters, such as the number of parameters you want to use for that simulation, the array jobs is definitely for you. So here in this bash script, I say run 12 instances of myscript.py from 1 to 20, and at every point in time, have 5 of these running. So if you have 5 running, when the first one ends, the 6th one starts, but 5 are still running. You can also just have them go from 1 to 20, where you just running one job at a time. And then here I show the different referencing used for variables within SLURM. So you have the substitutions and environment variables. The substitutions are basically used within the SBash script. That's for naming your logs or whatever result files that you get from the job. So you output your errors. They will have some conventional naming given that are relating to the job that you're running. And then your environment variables are used within the environment of SLURM, where all the computation is made. So if I just go back to the array job, you can see here I have singularity execute Python, my script, input, and then I have this SLURM array task ID. So this variable is going to be used within the environment to run whatever computation that's needed. And then, so finally, I show here dependencies. This is where you can run or schedule jobs to run based on the status of the previous job. So if you have one job, depending on the other output of another job, so you can have that set up. This will be elaborated further in the next training sessions. So, and then, so last but not least, keeping tidy and orderly using bash scripts rather than interactive session, identifying job resources requirements. There's a document for allocating efficient requirements for the jobs that you want to run on the system, and basically removing all the raw data, using already existing packages by either loading them or using singularity containers that are good for reproducibility, and also do not run software on the login node, because there's not enough space to be running anything there. That's why there's compute nodes and different partitions. And then having large files in the home directory, that's not very advisable. And also not transferring data using SCP and rsync in the login node. And yeah, that's all from me. I'll hand over to Jordan to finish up off. Thank you.
Cool, so you should be able to see my full presentation screen and my Chrome window. So just object if you don't. So thanks, Hope and Robin and Jeremy. So I'm just going to finish up with the data transfer services that we offer on ilifu. So you can go to our documentation page and read about this, but the short of it is we offer a transfer node as well as Globus. It's important that you don't use the login node. Like Hope was just saying, this is a shared resource for people, users submitting SLURM jobs to the compute nodes. It's a small resource, so it's important that it doesn't get congested with things like transferring. And in fact, you will be severely limited if you attempt to transfer on the login node, so it won't even give you a good service. It won't be fast or anything like that. And so if you have small transfers or less frequent transfers, you probably want to make use of the transfer node, transfer.ilifu.ac.za. So for instance, you could run CP copy or SCP secure copy or rsync. Perhaps you want to copy, say, some scripts directory internally from one file system on ilifu to another. So that's the first example that I have here. You would use CP option RA, which is a recursive archive copy. In other words, copy the entire directory and don't change the permissions or metadata, the timestamps and so on. Or perhaps you want to do an external transfer, say from your desktop to a path on ilifu, and that's what the second example is here, calling SCP, providing the path to your file on your desktop, and then your username at transfer.ilifu, and then the path to where you want to transfer it. So this would be the use case for the transfer node. However, we do recommend that you rather make use of Globus, particularly for more frequent transfers or large transfers. It's much faster than SCP and rsync. So for instance, locally, to say from the Sorreo archive to the CHPC or some other local server, we can get a few to 10 gigabits per second. And then we've also measured transfer speeds to Perth and to the Netherlands, which are 1.2 and 5 gigabits per second. This is compared to tens of megabits per second with SCP and rsync. So it's really much faster. It uses a dedicated transfer node. And so it's much better at handling the traffic rather than the small resources on the transfer.ilifu node. And it also checks the file integrity afterward, optionally at least, so that you don't have to worry about whether the file landed intact. And so this, as well as other functionality from rsync, is really the same available within Globus, such as, syncing between two different machines. You can only transfer new data that's arrived on source that's missing from target. You can delete from source after transferring and verifying to target and so on. And so I'll just quickly flash up the documentation we have on this, just to show you just how user-friendly and easy to install it is. So you can go to the Globus page and you can log in with your credentials, say your university credentials or perhaps Google or Orchid ID credentials. Once you've done that, you can navigate to the collection page and search for ilifu. That will then bring up a screen like this, which prompts you to put in your username and password, the same that you would use for Jupyter. And then from here, you can instantly pull up your files in the file manager. And then from there, you'd want to set up another endpoint. If you have access to an existing one, say the CHPC or something like that, you could instantly pull that up. Or otherwise, you can set one up on your desktop. And I'll just, for instance, flash up the installation instructions for Mac OS X, which is what I'm on. So it's very easy. You just click on this button, download and install the DMG, and then you can configure your preferences, such as where you want to be able to read and write on your desktop. So for instance, for me, I just write to downloads. And so it's really user-friendly. And then once you've done all that, you can very quickly set up a transfer. So I'll just go back to this page. So it really does offer a user-friendly interface via a web app that I'm about to demonstrate. But if you want to script it, you can also use the command line interface. But underneath that, under the hood, it's using grid FTP. So it's a very efficient transfer service while being user-friendly. And as I've shown, you can set it up on these different operating systems, on a server, your desktop, and so on. And so our use case for this is larger files or more frequent transfers. So you would go to the file manager, you would interactively click on and set up your transfer, and it would just run this in the background for you. It avoids fiddling with SCP and needing to keep an active internet connection and potentially having long wait times. There's one small downside, which is that symbolic links aren't included, but this is really easy to address by configuring your transfer in a particular way that I'll show to preserve the source modification times, which can then easily be repaired with rsync, which just really quickly copies those pretty much kilobyte sized symlinks, possibly even byte-sized symlinks, and repair the file structure. So I'm now quickly going to do a demo. So I have up here the Globus app installed. So for instance, I could go to collection details and this pulls up the link for me. It's nice and handy. I can then go to endpoints and for instance, go to the ilifu DTN. And then I can activate this. So that will ask me for my credentials. I then activate it and you'll see over here, it activates it for a certain time period. I can then, so I have some bookmarks here. I can go to a particular directory for this demo and I can configure a transfer from here. I just quickly want to show you, for instance, how you can navigate to the different paths. So I can go to /IDIA and you can see, say I could pull up projects and it'll show me the directory contents. It respects the permissions. So say I go to a directory I don't have permission to view, it'll show me this, which is good. And then, for instance, I can go one folder up and I can use this really user-friendly file manager to navigate the paths. But say I want to go back to this demo directory and I click on the file I want to transfer, and on the other, I need to set up the receiving end, so I can go to this Mac demo. Okay, there we go. I thought I'd lost connection for a second there. So I can go, say, to this bookmarks page. So this is actually something that, so it's an empty folder. I can show you, this is my file, my Finder window of that directory. I can then set up the transfer options. So this is the stuff I was talking about, like rsync, where you can only transfer new or change files, delete files on destination that don't exist on source. And then something that I think is useful to tick is to preserve the source file modification times in case there's symbolic links. You can select to not verify file integrity if you want it to be faster, but I think it's a good thing to do anyway, and it doesn't take long. And then there's a few other more technical configurations that are quite useful as well. So I can get rid of that. I can click on start. So it's going to go from there to there. It'll show me that it's submitted the request successfully. I can go and view those details. If I want to read about it, I can look at the event log. You can see it started. If there's any faults, it'll record them here. I can, I dare say by now, will have finished, probably just slow in updating. You can see the status up here as well. And then you can see it shows you that it's succeeded. And then on this end, you can see I've got this file over here. So there's a lot more we could show, but the main point there was just to show the user-friendly interface of Globus. So we do heavily recommend that you get set up with that. I hope I've shown you that it's easy to do. So that's everything I wanted to present. So we're going to open now for questions. Thanks.
Cool, fantastic. Thanks, Jordan. Thanks, Robin and Hope for presenting. So we do have a couple of questions. I want to go through the ones that, even though we have actually answered them, some of them in chat, I think it's just worth speaking about them for everyone's sake. So if you, I'll go through the questions that have been asked so far, but if you want to raise your hand or post questions in the chat, anybody's welcome to. Happy to go through any details of the material covered today, or if you have any questions from last session or any issues that you want to raise, we are live in here. Good resource at the moment for any questions. So starting, Jess has asked, so using VirtualBox machine to access the cluster, do I have to use that VM's internet browser to access RStudio like this, or can I use my host internet browser? So the main issue or answer to the question is that the way that the RStudio is portrayed in your internet browser is over SSH tunneling. So it basically exposes a port between ilifu and your computer over SSH. So what's important here is that if you can SSH to ilifu from your host machine instead of the VirtualBox virtual machine, then you would be able to open the RStudio session inside your browser on your host. So it really depends on where or how you have access to ilifu via SSH. Sriram has asked, does SLURM also do container management like Kubernetes and OpenShift? The answer to that is that, no, SLURM is just a workload manager to basically manage the resources in the cluster and to queue and schedule jobs to the resources. And it manages like accounting information and for projects and also kind of in a sense charges usage against accounts, that kind of thing. So no, it doesn't provide like a container management. We offer software in Singularity containers as well as software modules that the modules Robin demonstrated in the first presentation, and then obviously the Python virtual environments also available. So when you submit a job or launch a job, you would have to specify the container or module that contains the software that you want to run. Robin also mentioned that the use case is slightly different with Kubernetes. The containers are constantly running, where for our cluster, software and containers are basically application specific and are called when you run the job. Then Sriram just had a response. So if I made changes within a container, such as installing a package, I'd have to extract the image I wanted and run it again. So in terms of like kind of on the fly software changes, the Singularity containers are static. And the difference between Singularity and say Docker is that Singularity maintains permissions outside of the container to the, internal to the container. So I actually don't believe that you can install software inside a container when you've shelled into the container or through a script. I think you would get a permission denied error. So I guess the background to this question is probably like, how do you manage like a development environment with the software or the software kind of paradigms that we have. You would have to rebuild a container with the software that you require. So if you want, we obviously manage or maintain a bunch of containers, so you can put in a request to add software or create a new container. Alternatively, if it's something like Python or R, you can obviously load modules and install for R. In R's case, you can install R packages in your user space, and in Python's case, you can create a virtual environment for that use case. Yeah, those are, there's, I guess, with a little bit more flexibility, you can even use a container and build a virtual environment inside a container. And then that way you have access to other libraries or packages that might be available in the container. Sriram, I hope that answers your question. I don't know if I mentioned, but a container is also static. So they have like the format that they are built in are static, so they can't actually change or be change the way the Docker images are created.
Can I just add to that?
For sure, Robin, go ahead.
Yeah, so you can build a Singularity sandbox container, which basically just creates like a folder structure of your container, and you can add to that and then build an image from that. So that's kind of if you want to develop a sort of software environment and play around with installing packages, then that's the way to do that. Yeah, you can check more into Sandbox and Singularity.
Cool, thanks, Rowan. Tombo has asked, can I use Globus to transfer data from my local machine to IDIA? Jordan has responded, but the answer is yes. So Globus, so we host a Globus endpoint on a data transfer network, so like a single VM at IDIA. So that's dedicated for as a Globus endpoint, and you're able to either install Globus at an institution that you might be involved in, another HPC, for example, or you can install Globus. I think it's called Globus Client Connect, and that's available to install on your local machine. I think it has it's entirely created in like well, provides like a web a web browser interface for transferring data. So then that is a very good way for you to transfer data from your local machine to IDIA storage. Cool. So those are the questions so far.